This is 4b. Use the second derivative of h to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time equal 3. So the idea is very simple. We knew that we would have a graph of h that would look, all we know is that h goes down because h prime is always negative. So because h prime is always negative, we assumed h maybe did something like this. We created a line tangent. Let's make that a little bit better. So we had a graph of h, and because we figured out earlier that h prime, like we figured out here, remember, that h prime would always be negative. So because we know h prime is always negative, we know the graph of h is always decreasing. If the graph of h decreases something like this, where h is concave up, then we know when we create a line tangent to h, right here at time equals 0, we create that line tangent, that the tangent line will always be below h. So when we came out here to time equal 3, and we found this y-coordinate, and we said that value of 43 was a pretty good estimate for the temperature of the potato, the actual temperature of the potato would have been higher if h were concave up. This is the case where h is concave up. If h were concave down, however, so again, I'm not doing this problem, I'm doing the idea so you can solve any problem. If h were concave down and we had drawn a tangent line, the temperature we would have found would have been above the actual value of the temperature of h. Like we would have found this y-coordinate of 43, and the actual temperature of the potato would have been this y-coordinate. So that would have given us an overestimate. So here we would have an overestimate. Here we would have an underestimate. So we go back to looking at the second derivative. So we've got to find the second derivative. So we take the derivative of this. So the second derivative will equal, the negative 1/4 is a multiplying constant, so you just write it down. Within the parentheses, we have to take the derivative of h. That would be dh dt. Right here. So here's our multiplying constant. We'd have dh dt. The derivative of the 27 alone would be 0. And then dh dt is this formula. But we already figured out that this formula is always negative because h is always above 27. A negative multiplied by negative is a positive. That means that h is always concave up. So this is the correct picture. H is always concave up, meaning our approximation of 43 degrees at time equal 3 is definitely an underestimate. Now that's quite a bit of work for one point, but that's what you get. You have to show the derivative. You have to show, you don't have to show really, you just have to state that that derivative is positive, causing h to always be concave up, which means the tangent line approximation is an underestimate. So 1 point for all of that. If you have anything left out, they won't give you the point.